Hi, welcome to episode 5 of Coding with Amadeus. In today's episode, we'll take a look at the weather module and transit module. It's been a month since the last episode and I really apologize for the delay. I've been blocked on one element of the smart mirror, namely the weather API, but I'll show you in a bit what went wrong and how to address it. Let's see what's new. This is the clock view that we saw earlier. I added 3 more screens. One of them is the upcoming weather in the next 24 hours. Then we have weather in upcoming week. We also have a transit view, which tells me when I need to leave to catch a bus. This all is glued together with a navigation controller, which currently handles keyboard events. And in the next episode, we will handle GPOI input for the motion sensor. Let's take a look at the code. I added the transit module and the weather module, and you can see that they are much bigger than the previous clock module, which just had a model which contained our data, the current time, the view model which translated that data into a primitive such as string, and the view which displayed everything. Here we have weather, which contains one model which stores forecast data and sunrise and sunset information. We have the weather today view and the view model, and weather this week view and view model. You will notice that we have a weather model. We also have weather model underscore fake and weather model underscore W underground. Both of those classes, fake and W underground, they inherit from weather model. And here's what's up with them. The reason I was blocked for so long was that I was working with Open Weather Map API and I ran into some troubles. The API was targeting .NET 4.5. I wanted to convert it to Universal Windows platform and create a Nugget package and shoot a podcast about it. And this turned out to take so much time, it wasn't really worth it. I will still get back to it, but here's how I address this issue. I created this weather model whose sole responsibility is to store information. It tells us what is the weather going to be like in upcoming week and in upcoming 24 hours. And here we have the fake and W underground, which actually supplies data to this model. This W underground will be working with the wunderground.com API. If you're working with another provider, you can use the same pattern to just create a type for that particular provider, which inherits from weather model, which actually contains the data structures used by the view models. Here we also have weather model underscore fake, and all it does, every 10 seconds, it generates completely random data, so that in a view, when we're testing how everything looks like, we see a bunch of data, we see how it looks like. This pattern will be more obvious when we talk about transit. So we all live in different cities, and every city has a different transit provider. Therefore, it makes perfect sense to create a unified model within the smart mirror, which contains the information that we want to display, such as what's the bus name, what's the bus stop name, and when are the buses coming, and have individual classes which handle implementation of talking to the API. I don't have one yet, so I created a fake one, which every 2 seconds tells that there is some new bus coming to one of those 4 predefined stops. Let's take a look at some highlights. The first interesting piece of code I wanted to show you is in the weather view model, where we don't just have primitive types such as bool or string. Here we have a type, hourly forecast view model, and IEnumerable of hourly forecast view model. So how does view model display it? Let's go to the weather today view model, And I'll quickly walk you through what's happening right here. Right here in the top left corner we have the current temperature. Here we have current conditions, and if it's sunny, here we show when is the rain going to start. And if it's raining right now, we'll display when the rain will stop. And here are hours: 8 a.m., 9 a.m., 10 a.m., the temperature, the rainfall, the snowfall, conditions. When was the weather last updated from the server? Sunrise and sunset. So let's try to map those elements to what we see in a view model. Initialized. We don't see it just yet. I will use initialize to disable the screen before we make the initial internet connection, when we're still awaiting the response. It shouldn't be a frequent case, but just for the sake of completion, I added that. The string last updated is displayed right here. Rain forecast is rain starts at 10 a.m. Sunrise and sunset are right here. So we are left with the IEnumerable of hourly forecast view model right here, which is displayed in the list view. And we have the current time and the conditions here, which are not accounted for. So these are actually taken from the hourly forecast view model of name current weather. Let's take a look at it. This class contains just the primitive types. So we'll be taking the temperature and we'll be taking the conditions from this class. Now, how does the view access a property temperature or conditions from a type? In the weather today view, text block right here, the binding path is to current weather dot temperature. So current weather is taken from here, and then with the dot we're actually going inside of current weather, and now we can access time, temperature, conditions. So here we're accessing temperature, and in the top right corner we're accessing conditions. And the second new concept that we're introducing is the list view that contains multiple instances of the hourly forecast view model. So we have the list view right here, whose item source comes from property forecast. So with this code, I'm telling WPF that I want to have a list view which takes its data from forecast. The data should be displayed in items stack panel, a horizontal one, and that's why all the elements are displayed one next to another. And all the elements are displayed using a vertical stack panel that has 5 text blocks. And here's the stack panel with 5 text blocks. There's a subtle difference between accessing time, temperature, conditions here in a template from how we're doing that earlier for the current temperature and current conditions. We are not using forecast.time. The reason why we don't do it is inside the item template, the WPF assumes that we are already inside the hourly forecast view model. We can use all of those properties inside of the data template. Let's take a look at the transit module, which is fairly similar to the weather module with one exception. In the weather module, whenever the weather changes, we completely remove the old data and we recreate new data structures. That's why in the view model, the hourly forecast view model doesn't need to notify property change because everything gets removed. Now with the transit module, we have a list of bus routes and bus stops, such as 1 eastbound, 99 eastbound, 99 westbound. Each one of those bus routes has a list of bus arrivals. And the difference is that the list of bus routes is fixed. It is being created at the beginning of the application, and we don't remove that. We are updating the list of arrivals. So the view model is fairly similar to the clock view model. We just have the basic properties such as initialized, last updated, and we also have a list of transit line view model. So this is being displayed vertically here. This is a line, this is another line, and so on. Each transit line view model has a route name, a stop name, and a collection of arrivals. An observable collection means that if we add an element arrival view model to this list of arrivals, WPF will automatically update the list right here in a view, so we don't need to do it. And for the sake of completeness, let's take a look at arrival view model. It contains two strings: when I need to leave in 4 minutes and arrival time. Let's go back to that transit view model where everything happens. When we first initialize the view model, we call a method prepareLines. And what it does, it asks the model for all the transit lines that are out there and creates a view model for that line, where we're just copying verbatim the route name and the stop name. For arrivals, we're instantiating a new observable collection. And I want to talk to you about this line. This line is the key of what's happening in the transit view model. Line is a transit line. And the transit line has an observable collection of arrivals. And just to make an argument, we'll create an enumerable of datetime and we'll call it arrivals enumerable get set. And we'll investigate the differences between the observable collection and enumerable. When I say line.arrivals enumerable, I mostly have the link extension methods which allow me to go through that enumerable in whichever way I want. But line.arrivals has something extra. Because it's an observable collection, it exposes an event CollectionChanged. And we can try to implement this event. For this example, we'll quickly use a unit test, so I will introduce it right now. We have a very simple test which creates a mock transit model which allows us to add an arrival to the first of the lines. So the line Broadway westbound 1 will keep getting arrivals whenever we call the method addArrival. And here we are actually calling method addArrival. And what the test does, we want to check if it correctly shows the time when we need to leave to catch that bus. Anyways, we are adding an arrival. And all it does, it adds an element to an observable collection, which means that here in the view model, our event arrivals CollectionChanged 1 will be hit. So let's see what happens. We don't need that exception here. We are receiving sender, which is a date time when the bus is coming. We can also access this information through the event args. The action is add, so the collection tells us that something got added. We also have new items, so let's take a look. For each var new item in new items, it's just one item. The bus is coming at 3:48. So we have this information that there's a new arrival, but we don't know which line it is. We have no access to the line. We do, however, have access to the line right here, earlier in prepareLines. It is line. We have this information right here. And right here is a notation which I learned just earlier this year, which allows us to create an inline event handler. For example, I could say system.diagnostics.debug.writeLine e.newItems.first0.toString. Just very simple debug code which will essentially tell us what is the first element which got added. So we can replace the whole method here with this inline notation right here. Take a look at this method signature. It takes two params, an object sender and NotifyCollection.CHanged event args e. So here we can just say S for sender and E for the NotifyCollection.CHanged event args, such that, and here is our method. And this code is equivalent to this code. And there is this one extra thing which allows us to do so much more. We have to handle an event with a method that takes two parameters, sender and event args. But inline methods allow us to quickly create an invocation to a method which takes three parameters, so that we can pass in more context to our actual event handler. So in our case, we're immediately calling method updateLine, where we are looking the view model equivalent of the transit line, and we are constructing the arrival view model, which contains strings that will be displayed in the GUI. Observable collection, the GUI will be automatically updated. Let's see what it takes to add those 3 pages to our program. In app.xaml I added the view models to the resources, and then in app we need to find a way to navigate to those elements. The way navigation is done is by calling rootFrame.navigate and providing a type. So we have type clock view, and we have new types: weather today view, weather this week view, and transit view. And we want to do it whenever user is pressing a keyboard key, and in the future doing the gesture. So I need to create one place that handles the navigation. So I created the navigation controller. The navigation is done from within app.xaml.cs because I want there to be only one place where you add the new modules of the smart mirror. So here we added the view models, and here we are providing the types of the views. And also here is the method which navigates to the provided screen. So I wanted the navigation controller to take advantage of the screens which are provided here and invoke this launch screen callback to actually navigate. So we create a new navigation controller and we pass in the available screens and launch screen callback. It's not obvious how to pass in a method as a parameter to another method, but there's a really cool technique in Visual Studio which allows you to do it. Let's create a sample method which takes the list of types as a parameter, and also the callback method as a parameter, launch screen callback. Now when we hit Control dot, Visual Studio offers us to generate the method, and here we see that the method is provided as a parameter of type action. Yeah, without really getting into how it's done, this approach works. And that's how we are doing in Navigation Controller. The constructor takes a list of screens and a callback, and then whenever we receive a keyboard event, such as that the right key or left key was pressed, we cycle to a different screen and invoke the launch callback, which is provided to us. We will do some hands-on work. We will wire the motion detectors to Raspberry Pi, and hopefully in the navigation controller we'll somehow find a way to handle the events from the IO pins, and we'll be able to call navigate next and navigate previous from the hand gestures. I'm really excited for that, and I'll see you soon, and I promise you sooner than 30 days. Actually, I will start recording the next podcast right now.